This video is going to have a look at how do we use adjacency matrices to calculate the number of two-step connections between two objects. An adjacency matrix allows us to represent the number of connections between two objects. Go and have a look at the video introducing adjacency matrices if you need more information on what they are or how we can create an adjacency matrix. So this video is going to have a look at adjacency matrices and how we can use them to determine the number of connections available if we're going to be traveling indirectly through another object within the network. So this is known as two steps, but it might be more than two steps. It might be 3 steps or 4 steps, depending on how many other locations or how many other objects we are going to be going through to get to our destination. So to be able to calculate the number of paths possible when we're going indirectly through other objects, we raise the original matrix to the power of the number of steps in our connection. So for example, if we're looking at traveling through another object, a 2-step connection, then we're going to raise the original matrix to the power of 2. If we're looking at a 3-step connection, so we're looking at traveling via 2 different other objects before getting to our third and final object, we would raise the original matrix to the power of 3. So let's have a look at how we would apply this to an example. So in the example, we have the following adjacency matrix that shows the number of pathways between 4 attractions at the zoo. So we've got lions, seals, monkeys, and elephants. We want to determine how many ways a family can travel from the lions to the monkeys via one of the other attractions. So we're looking at starting at the lions and going to one of another attraction, and then looking up at being at the monkeys. So this is going to be a 2-step connection because we're traveling through one other object to get to our final destination. So the 2 steps would be to the other object and then to the final object being the monkeys. So to be able to calculate a 2-step connection, we need to take our original matrices and apply it to the power of 2. So we want to square that original matrix. So let's have a look at how we can complete this calculation before we can go ahead and work out how many different ways a family can travel from the lions to the monkeys via that other location. So when I am squaring the original matrix or raising it to the power of 2, I'm really taking it and timesing it by itself. So to complete my multiplication, I'm going to start off by taking the first column in the first matrix and multiplying it by the second column in the second matrix. So that is going to be 0, 1, 1, 1, 0, 1, 1, 1. And then I'm going to go ahead and multiply each of those numbers together to complete the table. So next I'm going to do the same thing, but for my next table, it's going to be the second column of the first matrix multiplied by the second row of the second matrix. So that is going to be 1, 0, 1, 1 multiplied by 1, 0, 1, 1. So I'm going to go ahead and multiply each of those numbers together. So next it's going to be the third column multiplied by the third row. So 1, 1, 0, 2 and 1, 1, 0, 2, and going ahead and multiplying each of those combinations together to complete the table. And finally, I'm going to multiply the fourth column in the first matrix by the fourth row in the second matrix. So that is going to be 1, 1, 2, 0 and 1, 1, 2, 0. So now that I've gone ahead and filled out those 4 tables to multiply the corresponding rows in each of my original matrices, I can go ahead and add the elements together in each of my table to come up with the answer for my matrix that I am squaring. So now that I have the answer to when I square my original matrix, I can go ahead and use that to be able to calculate the number of possible connections going from the lion to the monkey via one of the other attractions. So to help me work out my answer, I'm going to go ahead and add my labels to my squared matrix. So LSME, LSME. Now I'm going to look at my answer, and I'm starting at the lions. So starting at the row of the lions, and I want to end up at the monkeys. So looking at the end place of the monkey, so looking at the column, and I can see where it's going to intersect. So I can tell that there's going to be 3 different pathways to go from the lions to the monkeys via one of the other attractions. So my answer is going to equal to 3 pathways. So that's an example of how I can use adjacency matrices to calculate the number of pathways where there is an indirect route, so going more than one step.